Hey, welcome to section 2.1, which is called Box Plots. Newspapers, magazines, evening news, commercials, internet, government bulletins, sports publications bombard you daily with data and statistics. As an informed citizen, you need to be able to interpret this information in order to make intelligent decisions. In this chapter, you will graph data sets in several different ways. You'll also study some numerical measures that help you better understand what a data set tells you. A good description of the dataset includes not only the measures of central tendency, such as the mean, median, mode, but the spread and distribution of the data as well. This is often done with a set of summary values or a graph. So we're going to go beyond just mean, median, mode, and we're going to start to study some new things that we haven't covered before. But before we do that, let's just go back and look at this example. All right? So Owen is a member of the Student Council and wants to present data about backpack safety to the school board. He collects these data, and yes, it's kind of weird, some people say this data, but these data because there's more than one more than one point, so we call it these data. Data is plural in this case. On the weights of backpacks of 30 randomly chosen students. How much does the typical backpack weigh at Owen's school? And also what we're going to do is we are also going to make a box plot. So we're also going to make a box plot. Okay, so what we're going to do is we're going to plug all of this into our calculator. Alright, so you go to your calculator. That's not the calculator that I wanted. We go to the calculator, you hit Stat, you hit Enter, and then you enter all of the data into list 1. Now, I did that already for us, so that way you wouldn't have to sit here and watch me put all this stuff in. So I went through and I checked, do I have 30 total data entry points? So if I go up, I go back here, here is my 30th one, so that means I probably entered all the data incorrectly. I didn't have extra stuff that I forgot that I added in on accident. I didn't forget one or anything like that. Alright, so I have all of my data already in my stat. Alright, in stat. So what I want to do next is we can go to stat, let's go over to calc, and hit enter. We want to say, yes, we want list 1, frequency list, okay, and calculate. We just hit enter a couple of times in there, and you can see my mean is 10.2. This first one, x bar, is mean. So in case you forgot, we can say x bar, we're talking about the mean, and that equals, I think it was 10.2? 10.2. So there's one of our measures of central tendency. The next one, if we go down, you kind of remember the minimum, quartile 1, median, quartile 3, maximum. The median is going to be 9. Median equals 9. Alright? And then we have mean, median, mode. We would have to actually look at these and say which one is the mode. I see 10, 1, 2, 3, 4, 5, 6 times. Alright, so I see there are 6 tens. Let's see if there's anything else. Okay, so I just counted up the 10s and the 9s. 9 came up 5 times, 10 came up 6 times, so that means the mode is 10. Alright, so we have these different ways of describing what the typical backpack would weigh at Owen's school. Now, however, we are also going to make a box plot out of this. So if you remember going here and using the calculator, we already put it all in, and then you go to second y equals, number 1, I already have it all set up, it should be on, go to the dot plot, make sure it's list 1, frequency 1, and then hit graph, and here is our dot plot. If we now trace, you can say our minimum is 3, quartile 1, 7, median 9, quartile 3, 10, and maximum is 33. So there is a box plot that kind of represents everything. So if you see, most of our data is going to be in here. We have one number that's way out here, and we're actually going to just find that, something called an outlier. Alright, but now what we're going to do is we're going to take a few notes. I'd rather do this here than in class because you don't really need me in person to be doing these notes. So if you will, copy these down somewhere into your notes because you're going to need to know all this stuff. It's kind of new. Alright, so the data set in example 1 did not include every student in the school, so it may or may not tell much about all the students and all what their backpacks weigh. If Owen took his sample from the first 30 students who arrived to a single class, then the data might seem biased or unfair, as that means it could represent students who hurry to class because their backpacks are too heavy. How might the information be biased if Owen took the sample from the first 30 volunteers? Well, the first 30 people who volunteer might be the first 30 people he sees, which might be his friends, which might be different depending on who his friends are. It could be the first 30 people who show up to school, and if they get here early, that might depend on that might change what the backpack weight might be. So it depends on where he gets his volunteers. And if you actually go back to here, look at the grades from every single student. Juniors, seniors, juniors and seniors, juniors and seniors. Did he really accurately represent the entire school if it's only juniors and seniors? Well, if there are freshmen and sophomores in his school, those people have not been represented at all in this data set. So it's probably not a very good sample. All right, if you assume Owen's data set are from a random sample of all students, then you can make some general conclusions about all backpacks at his school. The three values commonly used to describe a typical data value are the mean, the median, and the mode are all measures of central tendency. Okay, so this idea of random sample is something that statisticians use a lot to figure out, can I actually make it truly random? If you hear things about 4/5 of doctors or 2/3 of the country are in favor of something, then people have done a lot of work to make sure that it is a very random sample. Okay, so this doesn't appear to me to be a random sample unless there are only juniors and seniors at his school. All right, so let's go ahead and define some terms. So here are some terms, and I'm going to try and define them using Owen Student Council backpack data. Okay, biased. Is it unfair or not truly representative? The question is, how did Owen choose volunteers? If he only chose juniors and seniors, if he only chose his friends, that's going to be biased. And that is not a good type of data to represent the entire sample, the entire school, the entire population. Okay, a simple random sample. It's all students are equally likely to be selected. So again, how did Owen choose the volunteers? If he just got a list of all the possible students and then had some sort of random number generator or had something that would randomly choose the students, put all their names into a hat, shake it up, and then pick names, that would work out very well. If it didn't go that way, then it wouldn't be a simple random sample. It would be biased. Okay, unbiased estimates. Unbiased estimates. If there is a simple random sample, then the estimates are not biased, so the sample reflects what happened in the entire population. So we can say the smaller, instead of getting every single person to answer, if we just get a sample and that's random, we can say, well, based on this random sample, we can make assumptions about the entire population. Okay, the next term, representative. When the sample is unbiased, the sample is called representative of the population, meaning that we have an unbiased, we have a random sample, we can say that seems to represent the entire population. We don't need to have the entire population answer the question if we have a representative sample. All right, the next term is range. Range is the difference between the maximum and the minimum, and you have to subtract them. You get one number. Okay, so if we want to find our range, I'd take 33 and I would subtract 3. So the range for this case would be 3, right? So his would be 33 minus 3. Okay, interquartile range. That's the difference between quartile 3 and quartile 1. It kind of gives you a smaller set of the data to work from. So if we want to say quartile 1 is 7 and quartile 3 is 10, we would say the interquartile range is going to be 10 minus 7, which is 3. Okay, and then we also have the term outliers. Those are extreme values that give a large gap between a point and the rest of the data set. So are there any outliers? Is there anything that seems to be not close to all of these things? Way out here, this one that was 33, that seems to be an outlier. It's way far out. Okay, and then we have the last term, modified box plot. Any point that is more than 1.5 times the interquartile range from the ends, it should be from, not from the ends of the box are plotted as separate points. And actually our graphing calculator has that already built in. Okay, so we're going to make a modified box plot right now with our graphing calculator. This is a regular box plot. If I go to second y equals, I will go to my first stat. I'm going to go down, and you see that there are two that are very much alike. This was the regular box plot. This is the modified one. So if you hit enter, and then I hit graph, these ones are the points that are more than 1.5 times away from the interquartile range. So that means 1.5 away. All these are going to be outliers. All right. So there you go. And now we're going to go to the last example, example B. Use box plot above to analyze the backpack data. Well, we have that already, so this is going to be hopefully fairly simple and easy. What percentage of the data values is represented by the lower whisker? So we're saying right here, what percent? Well, each part is 1/4. So this is 1/4, this part is 1/4, this part is 1/4, and the upper whisker is 1/4. So that makes it 25%. What are the values for the first quartile, the median, and the third quartile? So if we want to find those, if I hit trace, I can just follow along. There's quartile 1 is 7. So we can say Q1 is 7. We can say the median is 9. And if you just want to write MED, that's all right for median, is 9. Quartile 3 is 10. So Q3 is 10. So to say, what is the 5-number summary? The 5-number summary, again, is minimum, the quartile 1, the median, quartile 3, and the maximum. So we just have to find all of those. So the minimum, again, I think was 3. Let's just go back. The minimum is 3, and then we go out to the maximum. And the maximum was 33. So minimum 3, maximum 33. Quartile 1 is 7, median is 9, quartile 3 is 10. There is our 5-number summary. Alright, so there you go. You had 2 examples and you had a couple of notes for definitions of new stuff.